Now I know you guys weren't in here when when went over the first half of this, but if you remember this chapter, at the beginning of this, we try to get the bases to the same. Do you remember that? When you had certain numbers, you try to get the bases the same. If the bases were the same, then you set the exponents equal to each other. Do you remember that? Can you do that in this situation? Is there any way to rig these numbers 7 and 80 to get them to have the same base? Not at all. So you can't really do that. So we need another option. What is that option, do you think?
Well,
Do you remember?
write it in logarithmic form. That's one way you can do it.
Yeah, you could. You could change it into logarithmic form. Absolutely, you could do that. And there's another way that we learned in this chapter. Yeah, take the log of both sides. Let's do it that way. All right. Now you're right. You could. I don't even know which one would be easier or quicker. They're probably about the
I
same.
know this one's easy, but let's.
Yeah, there might be some times where when you really have to take the log of both sides. I don't know. But in this situation, let's do that. Let's take the log of both sides. All right, because I think that's kind of what they're trying to teach you here. So we'll just do it like that. Yeah, see, by putting that log there, see, there was no way to get that n plus 3 out here unless you had a logarithm, because there's no rule that says you can do that, is there? So now with a logarithm, though, I can take this and I can chuck this out in front, and now we can work with this a little easier. So it's n plus 3. Thank you very much. So it's log 7 equals log 80. All right. Let's see. You could do a couple ways. I'm going to show you how I would like to do it. Some people, they love their calculators and they like to do stuff as quickly as they can in a calculator. And some people will put log of 7, put a decimal number here, put a decimal number here, then do the math with decimal numbers. I'm not going to do it that way. I'm going to wait to the very end and throw everything into the calculator all in one shot. Okay, that's how I'm going to teach you how to do it. So log of 7 is just a regular number, isn't it? So I'm going to distribute it through here just like you would any number. So it's going to be n log 7 plus 3 log 7 equals log 80. Now if you look at this, we're trying to solve for n, right? That's the whole idea. So I can get rid of this 3 log 7. How do I do that? Subtract. Everybody see that? I don't have to show it over here. You know it's going to go away, don't you? Now watch. This is n times a log of 7. Log 7, this is base 10, by the way, right? Log base 10, 7. It's just being multiplied by n. How do I get rid of this if it's being multiplied? Divide. So what do I have to do to the other side? I have to divide by log 7. Okay? So now that goes. Now I got n by itself. And I'm not going to sit here and show you how to do it on the calculator. You're going to have to practice that yourself, just for the sake of time.
Mr. Hamrick,
Yeah.
that step up there where you distributed it, could you
Yeah.
also divide both sides by log of 7 and then subtract?
Yeah, you could have done that. Yep, exactly. That might have been a little quicker. Yep, I didn't even think about that. I don't know. For some reason, I just see the distribute and I just go for it. You're right. You could have done that. You could have gone divide by log of 7 and then subtracted a 3. That would be the same exact thing. Okay? Try them both if you get a chance and see if they come to the same number. They will. All right? All right, here we go. Here's another one. It kind of looks like you might be able to get the same base, but can you, though? No, not. Now, if that was a 9, it'd be a different story, wouldn't it? All right, but it's not. So you can't really get the same base. So what are you going to do? Yeah, you're going to log both sides. So we're going to go log 3 to the n equals log 6 to the n minus 2. Take the n, put it out in front. So it's n, right, log 3 equals n minus 2. Now watch, since that's a sum, what should I do with that? Put it in parentheses. Good. And this is log 6. Let's see.
So yeah, divide by log of 6.
Do you want to do that? Do you want to... I think it might... I guess you could... I'm just going to keep them logs, unless you can find a more efficient way to do it. Okay. Again, I don't want to use my calculator early. I want to wait to the very end to use it. So let's just distribute it. Okay. So this is not going to change. And I'm going to take this and distribute it through here. So it's n log 6 minus 2 log 6. We want the n's on the same side, though, don't we? I got an n here, so let's take this and do what? Let's subtract it. So it's n log 3. Yep, minus n log 6 equals negative 2 log 6. We good?
Yeah.
We got n here and n here. I only want one of them. I don't want two of them, so I'm going to factor out a greatest common factor, which is an n, isn't it? So it's log 3 minus log 6 equals negative 2 log 6. This is all being multiplied by n, so we divide it by all this stuff. It's really just straight up basic algebra, isn't it? It's really not. There's really not much to the logs except from here to here. That was really the only log step, wasn't it? Everything else is just straight up. Well, yeah, from here to here, I guess, too. But from here on down, it's just straight up algebra. Now, you just throw that in a calculator, and hopefully you get,
5.169.
yep, 5.1699. You can do that on your own. We're not going to take the time to do that, okay? All right, here we go. All right, again, same situation. I've said this a couple times already. There's really no way we can get the bases to be the same, is there? Because you can't get 5 to anything that's going to be 30, can you? No. So, what are we going to do? Same thing we've been doing. Take log of both sides. Or you could, I don't know, would it be easier changing this to logarithmic form? You want to do that just for fun or not? Maybe not. Let's just do the logs. Let's stick.
If you do that, which side?
Yeah, then you got, then that does make a problem. Let's just do it like this. Let's just do it like this.
Why
What?
did you do 4x minus 1 log 5? Like, couldn't you do it that way?
Doesn't the log go?
Let's just do it like this. I don't know. No. Wait till we're done this problem. Alright, so let's just take the log of both sides. Alright? Again, we've done this, like, it seems like, what, 3 times already today? So 4x minus 1 out in front. Log 5. There are other options on how you could do this. Okay, I'm just not going to go through every single one. This is the one that seems most logical to me. Maybe not to everybody, but it might not be the most efficient way in the world to do it either. Let's do this. Since we don't have x's on the same side, let's do what Dallas was saying a little earlier. Instead of distributing this through, let's just get rid of the log 5 and put it over here. Is that all right? Because we just have one x, so it shouldn't be that big of a deal. So we divide by log 5.
So this right here looks like you do if you were to rewrite that in logarithmic, then you put the log on the right side, right? Because
Yeah.
what you've got right there on the right side is equal to
Right.
what you had rewritten in logarithmic.
Yep. Okay, you know what we should do? Don't even do this right here. Let's just do this in our head. What are we going to do here? We're going to add a 1, right? Correct?
Yep.
Okay,
You say so.
we get rid of this. If I say so, it's a minus 1. It's not because I say so, because, look, it's 4x minus 1. How do I get rid of the minus 1? I add a 1 to both sides. So it's not just because I say so, right? It's because you know so, right? It's just basic algebra principle that you've done since pre-algebra. Now, you got to get rid of the 4. What do I do to get rid of the 4? Divide by 4. So I take this whole thing right here, right? And I just divide it by 4. I didn't do anything to that inequality, did I? No, I didn't multiply by negative or divide by negative or anything like that.
The log of 5
So-
is negative. Is the log of 5 negative?
No, these are going to be log base 10. I don't think it is because my answer is negative, is less than. So it's going to be, oops, I don't, what did I put equals for? Should be this, 0.7783. Yep. And that's it right there. Alright, this is a little bit different than we've been doing. You're not going to take the log of both sides right here. This is ln, natural log of this thing right here. You could just change this from logarithmic form into what? Exponential form. Let's see what happens there. Now, this is not just any old log. What is it? It's log base e. Alright, I'm going to write it out like this. You might be able to just do that first step in your head, but I'm going to write this out so we can see that this is actually a base e right here. So if I change this to exponential form, what are we going to put? E to the 4th equals x plus 4. Okay. Again, we're trying to solve for what? It just says solve. So yeah, solve for x, because that's our only variable here. So what do we do with this? Just subtract a 4. So it's going to be e to the 4th minus 4 equals x. All right, plug that in the calculator. Now, what's the e? How do you get e on your calculator? Hit the e button, right? So it's the second function, natural log. That's where the e button is. It says e to the x. You stick a 4, then you put minus 4, and you should get about 50.5982. All right, so you put e. Make sure you know how to get the e button to pop up on your calculator, because you put e to the first, right? So e to the first, or actually, it's not to the first this time, it's just e to the 4th. So you don't even put it first. You put e to the 4th, and then minus 1, and you should get that number right there. Alright, due to time, I just wrote down all the steps. First thing we did was take the natural log of both sides. right there. The natural log and the e cancel each other out, so you bring down the negative 3x. Divided both sides by negative 3. Since we divided by a negative, we change the direction so it's greater than or equal to. Put it in our calculator, and that's our answer. Let's go to 20 now. All right, the last question is a compounded continuously problem. I give you the formula on the test. It's right there. The e is that 2.718, right? It's that one that's associated with the natural log. And they say all this stuff. They say you deposit $3,000. That's the principal. They tell you the rate. Write it as a decimal. They tell you 5 years. The t is always written in terms of years. So now we just plug everything in, and its question says, what's your balance going to be after the 5 years? That's what the A represents, how much money you're going to get after the 5 years. So let's plug everything in and see what our answer is. We'll be done. All right, so here it is. I plugged everything into the formula. Just throw that onto your calculator. The E is the 2.718. Throw it in, and there is your answer, $3,315.51.